Hello, and thank you for joining the webcast, Increasing Cloud Application Performance in Emerging Markets. Before we get started, I'd like to invite you to enter your questions in the Q&A section of the ON24 console. And we will answer as many as possible at the end of the webcast. Today, we will begin with 451 Research Senior Analyst Jim Davis, who will give us the industry's perspective on cloud computing and increasing performance. After Jim, Jeff Kim, COO of CDNetworks, will go into more specifics on how a CDN can make a difference in improving performance of your website and cloud applications so your customers and employees have a great user experience. So let's get started with Jim Davis of 451 Research. Welcome, Jim.
Thank you, Sharon. Good to be here today. Thank you for those of you who have joined already. So I wanted to start the presentation by talking about the overall trends behind the cloud market and some of the issues that have come up with the use of cloud computing. My name, again, is Jim Davis. I'm a Senior Research Analyst with 451 Research. I'm based in San Francisco. What I wanted to talk about today was cloud and application performance. First, wanted to begin by talking about what are some of the trends driving enterprises to use the cloud, and what were some of the applications that they have already started to deploy in the cloud. The next thing I wanted to do was to talk about solving the cloud performance problem, the ways in which enterprises are dealing with issues that have arisen from the use of the cloud, which includes the possibility of data center build-outs, taking down co-location space, or using a CDN. And lastly, again, wanted to talk about how to connect cloud and CDN for better performance. So first, the move to the cloud. The broader trend that's driving cloud consumption, I think, is the consumerization of IT. In its most obvious form, this is seen in the waves of new smartphones that breach the boundaries of the IT department without formal approval, but have since become essential tools for businesses as they rethink how to reach out to their customers. In many other ways, this consumerization has manifested itself in a rethinking of how enterprise technologies are designed and consumed. Perhaps the most notable example of this is Amazon, the online retailer that has led the charge into cloud computing, where compute and storage resources can now be paid for on a credit card, used for a day or a month, and then shut down. What we're showing here in this slide is a growing market for cloud services. It's within this market that we're focusing on opportunities and challenges. 451 Research is expecting the market for infrastructure as a service to grow to $2.4 billion this year and growing further to $6.8 billion by 2015. I'll remark that this number isn't as huge as some of the cloud numbers that you'll see out in the marketplace. We're trying to be precise here today in not just letting anything be called cloud and putting it into a big number. We're including in these numbers both compute and storage services combined, as exemplified by Amazon EC2 and S3, or Rackspace Cloud Servers Cloud Files, as well as backup and archiving services from companies like Nurbonix, Carbonite, or VMware's Mozy. So again, we're really focused on infrastructure as a service numbers here. That being said, there's still explosive growth, CAGR of 49% over the years marked here on this slide. So this is most relevant to the question at hand today. How does an enterprise expand its ability to produce goods or services into emerging markets like Brazil, Russia, India, and China without overinvesting precious capital? This slide here gives a flavor of where people are using and buying cloud computing services. It is dominated by North American consumers or enterprises at the moment. 67% of the revenue of the market in 2011 was from North America. but we see a fair contingent over in EMEA. 21% of the revenue in 2011 was generated from EMEA, and Asia Pacific definitely lagging behind in the adoption of cloud computing services so far, but still growing pretty nicely, 11% last year. So we expect continued fast growth in these markets as they catch up to the notion and get used to the idea, as North American consumers already have, of buying services on demand. So another factor that has certainly given cloud computing services a fast launch is a whole generation of startups have adopted this rapidly. Speaking recently to the CTO of a U.S. telco, he was telling me that over the course of the last 12 months, he visited 400 startups, which made for a hectic travel schedule, of course, in the U.S., Israel, and Europe. And he was looking to partner with these companies and make sure that they were on top of innovative new strategies. Of those, 45% were using cloud as the basis for their business. They were not buying servers and storage and investing capital in that. They were busy building software and using cloud computing resources from companies like Amazon. Now, even enterprises of every stripe, from the smallest up to multinational corporations, are getting on board with cloud computing as well. They are conservative by nature, but there has been a more gradual adoption of cloud computing that we can still see growing over time. These numbers are from our end user research service, ChangeWave Research, and it shows several different surveys over time here, starting in 2006 and going up to, actually I think the years are wrong on that slide. Our most recent survey, finished in July, shows that 32% of end users surveyed are actually now using cloud computing services, and this compares to even just 22% at the start of this year. So what are some of the business processes that these companies have in the cloud? Well, we can see collaboration tools are definitely among those being used. Things like SharePoint, email is, I guess, an obvious first example. And then CRM tools like Salesforce.com. Those are other examples that end users have told us are in the cloud already. So another thing to consider today is, what are people doing next with the cloud? How are workloads changing over time? And we have another end user research service called the InfoPro, which does in-depth interviews with IT users. And the difference here is that we're really spending a lot of time getting to understand what precisely they're doing through in-depth, in-person interviews rather than simply surveys. So among the different types of things that people are going to be doing in the cloud, we can see that 31% are going to use cloud-based collaboration tools within the next 12 months. 53% are already using cloud-based human capital management, which does include things like human research management. Another 13% are going to start within the next 12 months. 50% have custom apps running on the cloud, and another 36% will be adding new applications in the next 12 to 24 months time frame. Growth is obviously a bit further out here, reflecting the time needed to develop new software, but we can see all kinds of different processes and applications that are moving to the cloud. Lots of stuff left to be done. I think a lot of these trends in terms of application use, we'll make note of these in Jeff's presentation as well. So there's a lot of amazing things that we can do in the cloud. Is it a cure-all for the enterprise? Well, it certainly solves a fundamental problem, especially in tough economic climate, of enabling business agility, but costing us less. We get resources on demand, we get programmatic access, and we get a pay-as-you-go business model. These are all great things to have, but there is a problem with the cloud. The cloud is not enough. There is a performance issue. Cloud resources aren't as ubiquitous as actual clouds, especially when we're talking about emerging markets like the BRIC countries. Virtualization of resources has many virtues, but in an age when workforces are widely distributed as well, how do we maintain needed levels of application performance in terms of the end user perspective? Well, getting closer to them is the primary answer. And there are a number of different ways in which we can do that, and some of the ways which you might be considering, one of which might be to build an enterprise data center. So why don't we think a bit about what are some of the typical costs for an enterprise data center build? Well, so costs can be impacted by a number of factors, including the current needs. You have to figure out what are your current application workloads, how much space are these going to require in the near term, and then also now try and guess what you're going to be doing in 5 years. You need to have enough space for all of the compute equipment, servers and storage and networking equipment, 5 years down the road. Otherwise, you've built a data center that's already outmoded almost before you've even started. Costs will also vary by facility type and location. There are a number of different standards to which you can build your data center. We can go for a gold-plated Tier 3 or 4 certified data center, but most enterprises are going to be a bit less assiduous in their data center build-outs. That being said, my colleagues over at the Uptime Institute, who engage in professional services with enterprises on an ongoing basis, we came up with a typical cost of $15 million per megawatts of IT load using traditional construction methods. If we start to talk about some more advanced construction methods using prefab modular data centers, we can cut that cost down considerably to $9 million per megawatt. Modular data centers are essentially those in which all of the equipment are needed come within a data center or a containerized ship, much like you'd see on a cargo ship. There is a trend towards folks selling these prefab data centers in a box and shipping them on site. This is an emerging method, but it's still not cheap. If we just assume a very modest need of, say, 3,000 square feet for an enterprise data center, which is not an atypical size, this is still about $4.5 to $7.5 million to build in just a single location. Now, another possibility to consider is to leverage the economies of scale from a provider like an Equinix and take down colo space. And we can see that there is space available in lots of these emerging markets, even though by the North American standards, the multi-tenant data center market in Russia and Brazil and China and these other areas are evolving, nascent in some cases. There is a growing supply of space for you to consider. We have some figures here about the amount of space in Moscow. So we can look at 2012 and we would see that there is just about 30,000 square meters of space available currently, and that should grow to almost 40,000 next year. So, we've solved one issue possibly by taking down colo space. We're saving money on not building a data center. We're getting closer to end users. But let's think about some of these costs as well. We still have some of the same capacity planning issues as building a data center. Not only do you have to consider needs now, but you have to consider how much space you're going to need 5 years down the road, because the provider is going to give you possibly a better price on the space based on how much you're taking down now. You could get a discount of as much as 25% depending on the length of the contract that you're signing. Again, costs vary by facility type and location. And so if we look at the typical cost, and I have an error in my slide here, it's not 200 million per kilowatt, it's $200 per kilowatt is an average price that we've seen across a number of engagements. You add in the cost of installation of equipment, cabinets, cabling, and of course you need to connect to the network. And we're still talking about $2 million a year for the first year alone in costs. We're getting in the right direction, but we're still tied into long-term deals here. So we might consider, well, can't I just move to a different cloud? Well, as I mentioned before, these facilities aren't ubiquitous themselves. If we look at moving our application to EC2 in Singapore, of course, performance in Singapore is fine, but performance in China, Japan, Australia is definitely subpar, as we see on the slide here. And we can notice some other anomalies. Even though Bangalore is physically a bit closer to Singapore, the performance is actually worse than you are seeing in Mumbai. We'll still see other issues. We could ask about page load times in China. I have pulled some data from Sodexis here. We can see a wide range of performance here, with ChinaNet being a factor faster than other networks, as judged by average page load times in China. We'll look at performance in Brazil here. We still have the same problem. If my user is located in Brazil, about the only provider that so far is actually located in Brazil is Amazon EC2. So they have substantially better performance. But if my application is hosted anywhere else, we have a significant difference in application performance for those users in Brazil. And we could see that error rates are another measure of performance. This is percentage of measurements that resulted in an error or timeout session. These are measured across different networks in Russia. So say, for instance, our hypothetical enterprise took down colo space in Moscow. We still have an issue here with performance across the different networks that our users in Russia are using. That's going to widely affect the performance of the application. So even if we're closer, we haven't solved all of the problems. And one of the things that I've been advocating to our audience, our clients, is that there needs to be a tighter connection between cloud and CDN for better performance. I think it's really in the connection of cloud and CDN that we get both the business advantages and the performance advantages of the consumption of applications over the cloud. We're not leaving users or capital stranded on a virtual island here. We have closer alignment of business needs. We have the on-demand resources from the cloud combined with enhanced performance from using a CDN, which is already deployed resources throughout networks to get your application closer to your end users. And with that, I'd like to hand it over to Jeff.
Terrific. Thank you, Jim. Hi. Let me My name is Jeff Kim. I'm the Chief Operating Officer of CDNetworks. Very nice to be speaking with you today. A bit about CDNetworks, just for everyone's reference. We are a 12-year-old company, originally founded in 2000. We are a global content delivery network. We have over 100 POPs, so we'll talk about our network coverage and what we do. One of our biggest strengths is our strengths in the emerging market, or the growth markets. That's where we started and where we continue to proliferate and differentiate ourselves. We have over 17,000 websites on our network, and we have been helping our customers get into the emerging markets and growth markets from day one. So we're an enterprise company serving enterprise companies in the growth markets. So very happy to be speaking about our expertise today on this webcast. So, our obligatory customer slide, we have customers around the globe from every industry, from media and entertainment to enterprise to cloud to everything under the sun. So in relation to today's subject, a lot of these customers have come to us when they need to get into China, or when they need to get into Russia, or they have performance problems in Indonesia or South America or the Middle East. Again, this is where CDNetworks shines. So sure, we can deliver in the UK and Germany and the US, but we are experts in delivering into the emerging growth markets. Okay. A bit about our solutions and network. I won't dive into this too much because this could take hours. But we have a large, massive network of 100 points of presence around the globe. And our network strategy and penetration strategy is really about growing in areas where your business is growing. So 25 points of presence in China, 13 points of presence in Russia. I think we're the only global CDN with POPs in Indonesia, expanding quite a bit in the Middle East, South America. We had one of our customers ask us if we could help them get into Cuba. So we don't have a POP in Cuba yet, but that's something we're working on. On top of this network, we have our Web Performance Suite, which is a whole suite of different products and services to accelerate your web application and your website. A lot of people think of CDNs as just caching, or streaming. So I want to deliver my video, or I have my caching objects on my website. So traditionally, that's where it's been, but you can see in the top left-hand corner of the slide, we provide all the services to accelerate your applications, from an accelerated DNS, cloud storage, cloud load balancer, and of course our premier products are our ability to accelerate your dynamic applications and transactions. So I say this quite a bit when I meet folks, but the internet has evolved from simple web pages or a network of a network to deliver simple web pages. It truly is an application delivery system. That's why there's so much excitement these days about big data and performance scientists and front end optimization and all of these different things, because we're kind of at the next evolutionary stage of the internet of making it an operating system where you can put your dynamic applications and it will perform reliably with high performance and with security and et cetera. So basically all of these applications that are locked up in private networks and private applications are coming onto the internet, and folks like CDNetworks, we're in the business to allow that to succeed on the public web. All right, so let's talk a bit about the emerging markets. You're here because you're interested in the emerging markets, so I won't bore you to death with this. I took the GLOBALITY, so Mary Meeker in one of her latest web conferences basically has figures on the growth of the internet. And not surprisingly, or maybe surprisingly to some of you, the U.S. is ranked 8th in terms of growth. So the big growth markets now on the web and in every industry that we see and all the customers that we are working with are in the growth markets. So China, Russia, what else is it? Indonesia, Nigeria, Russia. So It's all of the growth markets there that you're seeing a lot of the shift of e-commerce, a lot of shift of enterprise software. Some other clips that we showed there is, of course, China's big in the news. They have more internet users than whole countries combined. And then Russia is starting to boom, and South America is, of course, a huge internet environment as well. So you already know this, and that's why your applications, or your web businesses want to get into these areas for growth. A bit about the problem. So as Jim mentioned, a lot of you may have already made your migration to the cloud. So terrific, check. So you have the scalability. You have the ability to dynamically increase capacity. You're saving money in terms of shifting fixed CapEx dollars into a monthly recurring OpEx. Terrific. The problem is your cloud, while it's a good metaphor, is still physically centralized somewhere. It's still ping, pipe, and power. That hasn't changed. So whether that cloud is hosted in Oregon or Dallas or Ireland or Singapore or the UK, there's still some physical machines that are tied to some physical network on the web. Okay? So that of course. And what happens is, again, no matter what you choose, right near your cloud or your private cloud or your public cloud, you have fast application performance, happy users. So if you have your cloud again in Oregon, then people in Oregon are going to be very happy with fast performance. But as soon as your extended enterprise of customers, end users, employees, partners, vendors are in remote locations like Australia or Germany or China, all of a sudden you have slow application performance, unusable applications, unhappy users. So that investment in the cloud that you made, which is brilliant and fantastic, your application is unusable, or your enterprise is not happy with them. So why that is this problem with the middle mile. And what that basically means is, the chart kind of shows, okay, you're hosted in Oregon, your application performance in your Oregon is great. In New York or is pretty good, and the farther and farther you get away, the worse it gets. A lot of people still think this is a bandwidth problem. This is not a bandwidth problem. So even if you had infinite bandwidth, this would still happen just because of the middle mile. And what that basically means is the internet was designed not to perform very well for applications. TCP/IP, built in 1970 or designed in 1973, which we're using today, was not optimized for dynamic transactions and the ability to go across vast distances like this. So until we get to the next generation internet, where all the protocols change, we are living with this problem. And our customers see it every day. We see this every day. So how do people solve this problem? And repeatedly, our customers come to us with the same types of solutions that they're seeking. Number one, and I would say the vast majority of our people that we talk to go for data center build-out, and this also is cloud build-out. Okay, so I'm in Oregon, but my users in Russia or China have poor performance. Let me get another cloud or data center in Hong Kong. And I'll go through the painful process of building that up, replicating my applications between Hong Kong and Oregon, and let me try to figure that out. That still doesn't work because you still have users in Dubai and Germany and Australia, and this is a nuance, but even hosting in Hong Kong, your performance in China is still not that good. So even with all of that capital expenditure and more build-out and replication and throwing IT at it, problem is not solved. Second thing is application appliances. So these are the hardware that you buy from Riverbed and Cisco and F5, and they'll be happy to sell you big expensive boxes. Unfortunately, you can't put a box at every single end user, and that's a going trend. End users and your extended enterprise are continuing to extend. It's not like they have a fixed branch office. So application appliances are great if you have a static fixed branch office and you have to connect them to your headquarters. But as users move across the globe and it gets more and more, you can't put an application appliance everywhere. And the third solution is, okay, we heard about CDN services. Let me go ahead and go with a traditional CDN service that can cache some of my pages. That's a good intermediate step. Unfortunately, applications these days are highly dynamic. So your banking application, your Salesforce application, your CRM solutions are very dynamic in nature, and none of that can be cached. So these are the typical problems that we see when prospects or customers come to us. So our solution, what do we offer? I showed you a kind of a slide of our 100 points of presence and our product suite. What we basically do is we extend your cloud globally. So our 100 points of presence, you can think about it in a very simple analogy, are your 100 new cloud data centers. Okay? Now, we're not replicating your data, but we are now extending your single origin cloud in Oregon or Singapore into our 100 points of presence. And what we try to do is minimize the performance between your cloud and your end users by using our infrastructure. So your dynamic transactions are accelerated. Your DNS is distributed on our cloud. So a lot of times people forget about DNS and they go, okay, let me do this. But in many cases, we found out that the biggest problems are with our customers' DNS. So their end users in Russia, again, Australia, China are logging in, but their DNS server is sitting in Kentucky, and it takes several seconds for them to even look up where to go. So, we distribute that onto our cloud. Web content, of course, the cacheable web content is there. Media is distributed and cached on our network. Your storage, your core assets can be distributed. So we kind of put all of this together to accelerate your core web application. So leave your cloud wherever it is. Don't think about replicating and throwing more dollars at the problem. We'll go ahead and take your application or your data center or your cloud, wherever it is, and accelerate it to your end users. So that's a lot of high-level hand-waving and products and services. So it really comes down to what does that actually mean, okay, and how does that translate into success stories. So basically want to finish up and really highlight 3 customer success stories. Okay, so HighQ is a customer of ours. They are a collaboration and document sharing platform for law firms and banks. So it's a fantastic cloud solution, right? SaaS, where end users can come in, upload documents, share. As Jim was mentioning before, one of the key first applications that people put on the cloud are collaboration applications, and that's actually what we're seeing as well. So this is a collaboration tool and social kind of corporate social media tool for law firms and banks and financial institutions. Okay, they were hosted, or their cloud was hosted in London, and their UK performance is fantastic. Unfortunately, they have, like we mentioned, users everywhere. And so large corporate clients with global offices all around the globe, their collaboration was limited because if I have to upload a legal document and it's taken me several minutes, that's not a very good user experience. So the reputation was at risk, especially for cloud service. They looked at the first option I talked about, which is extending into other data centers, but it was very cost prohibitive. Okay? So even colos, and it's actually the software, the replication software, and load balancing, and all of that fits into going multi-data centers. In fact, the overall trend is to go against that. Actually, we have large customers that are going from like 33 data centers down to 3. So multiple data centers were a big going trend in the 90s and the early 2000s. But people are reversing that trend these days. So next slide is our success. So kind of an eye chart there, but you'll see the two red boxes that with us, their load times in Hong Kong were 23 seconds. So I don't know about you, but these days people won't even wait 4 seconds for a website to load. And so 23 seconds for a web app to finish or load is basically unusable. And we got that down to about 3 seconds. So HighQ's products, we put them on our web performance suite. They actually, the key product, the service that they use was our dynamic web acceleration. And users in both Australia and the U.S., their download speeds as well as their upload speeds, because it's bidirectional. So collaboration isn't just about, again, websites just aren't about downloading anymore. It's about interacting. So uploading, interacting, posting information. 2,000 to 1,000% respectively performance improvement. And they're highly happy and successful customer with us. Okay? Moving on to the next one, and you'll see that there's very similar stories here. So Thomsons is another cloud-based benefits management. So large corporate customers come to Thomsons. They have this web app, a SaaS-based application where employees can sign up for their employment corporate benefits. Okay. They had large strategic customers. Some of them in this specific one was in China. A highly dynamic application. Okay, so of course there's really not that much cacheable when you're looking at personal information that people are putting up there. So our HIPAA compliance, CDNetworks is HIPAA compliant, was also a very important thing for this as well. So their cloud again was based in London. And they were doing the same thing, costly data center builds out with replications all over the place. They have to solve this problem. This is their core business. They have signed large corporate customers. Corporate customers have employees all around the globe. This is not a optional thing for them. This is a mandatory thing for them to fix. So this kind of chart on top, the green is their, again, sorry for the eye chart here, is their performance from around the globe, from different, this was using Gomez, which is a third-party measurement tool, around the globe. And then the blue is the after, which is after they came onto our network, what was their performance look like? And you'll see that this is by jumping onto our web performance suite from 100 points of presence, what we basically do is normalize your performance. So regardless of where your origin is or where your end user is, we try to get a consistent end user performance, usually around 3 seconds or less, no matter where they're coming from. Okay? So the result, now, as I mentioned, all of their end users, wherever they're coming in from, whether it's Russia or Brazil, have 3-second load page times and a consistent user experience. And the little chart on the bottom basically shows a before and after. In fact, for some reason, their performance before from Shanghai, with their page was loading in 78 seconds. And we got them to load to about 1.5 seconds. So I hate showing numbers like this because 78 seconds is so crazy, but this is the reality of the things that we're seeing out there. We can take websites that are 20, 30, 40, 50, 70 seconds and get it down to performing in 3 seconds. Somewhat unbelievable, but I encourage you to come talk to us to see what we can do for you. The last case study, and again, at this point, it's almost getting kind of repetitive. SEMI is a global industry association serving the semiconductor industry, nano electronics. So they're hosted on Amazon, EC2, AWS EC2. They had a large IT staff and budget, and they spent a lot of CapEx and had the OpEx to manage those things. Unfortunately, that had to be optimized. They had a cloud-based system that they used Drupal for their CMS, but one of their biggest markets was in China. especially in the semiconductor industry. Their existing CDN provider didn't have points of presence in China, so they came to us. And I think their existing CDN provider only provided them with caching services as well. So that's option 3 that I mentioned earlier, which is a lot of people think of CDNs just as caching, and so that's what they were getting. We put them on our dynamic web and some other services. I think they may be on Cloud DNS, but I'm not sure. They went from 20 seconds down to 9 seconds, and less errors. So by going with our 100 points of presence, they put 25 of their different web microsites or different websites and web applications, and now their performance in China is fantastic. Okay. Now, in this specific one, you may say, hey, how come you couldn't get them down to 3 seconds instead of 9 seconds? Well, there's still think time, so there's still application think time within their origin or their cloud or their data center that still needs to do that processing. So that's one of the things that we work with our solutions, our sales engineers and solutions architect work with you to take a look at your application. We actually figure out, how long is your think time within your data center and how long is the latency caused by the general internet. We can help on the general internet, and we work with other partners that can help with you to optimize your think time within your data center. Okay? So that ends my presentation, and we can hand it over to Sharon for questions.
Great. Thanks a lot, Jeff. We do have a few questions. The first one is, I understand the potentially higher cost of co-location, and this is kind of going back to what Jim was talking about when he was talking about cost, but still don't understand why performance is worse than using a CDN if I'm co-located closer to those areas.
I would say that, as we saw in a couple of the slides there on performance in China and Russia, again, even if you've taken down co-location space in a major market, say Shanghai, there are a number of different networks, different physical networks that people will be accessing those applications over. And it's hard to see until you look at performance data, but just putting that application server in the market doesn't mean that every user in China is getting the same performance. There's a wide performance differential between the different network owners there, and that is, it might cause you to think, well, maybe I could put some servers in a couple more cities. Again, I think that still doesn't completely solve the problem. It's not a very cost-effective way to do it when you consider that a CDN has already invested those resources and put them closer to the end users. Why would you want to do that again yourself?
Anything to add?
Absolutely, and the other points are, and just to add on to what Jim was saying, that the internet is how it's networked is not so neatly organized. So I'll give you a good example. We put a POP in, I forget, Venezuela or Brazil or one of those South American countries, and our performance off of Gomez and Keynote and these other third parties didn't improve. And what we were figuring out was that particular POP was networked in through Miami. So our POP or our point of presence in Miami was better performing than our POP in South America. So that just shows that even if we put a location, let's say you choose to put a co-location facility in that particular country, if the networks aren't set up properly, you could actually be throwing money away because you're better performing in Miami or Dallas because that's where the network transit and peering is. So that's a good example of how working with the CDN, we navigate all through that because most of our POPs are multi-homed and multi-connected to all of the networks.
Great, thank you. And then there's two questions kind of similar. One, it's kind of more detail on what the middle mile is and how CDNetworks accelerates that middle mile to these points of presence.
Sure, I can take that one. Really, it's kind of CDN lingo. There's the first mile and the last mile. The first mile is where your cloud is and where your co-location or data center facility is, and how does your data center get connected up to the major broad internet. That's the first mile. The last mile, of course, is out to your end user. So how does your end user get onto the general internet? And The middle mile is everything in between. It's that network of networks that we call the internet, and the vast majority of the latency and performance issues are actually in the middle mile because people have invested heavily in the first and last mile. So when you buy your bandwidth connectivity for your data center, you know people are putting gigabit Ethernet and massive pipes there, and of course the end users are getting invested there. It's the middle mile that hasn't been really upgraded, and also the packet loss and the peering and all of that. So that's where our kind of technology and know-how of making TCP/IP better makes things work.
Great. Let's just do probably one more question here. What are some more examples of like this distance-related latency, and how can it affect both either static content or dynamic content? Is there a difference in the way it affects them? So examples of how latency can affect both static content and dynamic content.
Sure. So static content, that's a much easier problem. We just try to cache that as close to the end user as possible, and then the other thing is kind of a technical term, but a cache miss. So if the storage or the caching thing at the edge doesn't have enough memory, what will happen is that piece of content will get pushed out of cache, and then what you will have to do is go back to your origin to pull it. That's a very bad thing, because then now you're traveling over the internet and pulling it from your origin and then repopulating your cache. CDNetworks solves this by two problems. We have the highest cache hit rate in the industry. It's like 97-98%, meaning we have enough storage capacity at our 100 points of presence that once we cache something, it's pretty much there for at least a month, even if no one accesses it. That's not scientific, so don't hold me to that, but that's basically what it means. As well as, even if we do a cache miss, that pulling from origin pull is still accelerated over our dynamic solution. And then, of course, for our dynamic piece, we're doing our optimally tuned TCP magic to minimize the slowdown of the protocol over the internet.
Great. Okay, actually we have one more question that we'll go ahead and ask. Can your solution retain statefulness, session persistence, etc.?
Super technical question, but absolutely yes. So you'll see some of the applications that we work with, and I'll just give you examples like banking transactions, to ERPs, CRM systems, to gaming, where it's real-time gaming for massively multiplayer games and things like that. So we deal with crazy types of applications and expiry headers and TTLs and sessions. That's what we've been doing for 12 years, and we absolutely can support this.
Great. Thank you. Well, do you guys have any last comments that you would get across to our audience?
No, I just appreciate the opportunity to get to expound on the state of the cloud market. I appreciate having me here.
Great. Thank you. Well, thank you to all of the folks who joined us live and everyone viewing the recording. Thank you very much, and have a wonderful day. Thank you.